the beauty of computer vision is that we humans take it for granted. We're like, what is a car? It's so easy to recognize it. That's no problem. But it's really difficult for computers to actually do so, because how do you classify a car? There's wheels and things. What is wheels is round stuff, but what is round? So one of the fundamental problems of computer vision is to recognize objects in this way. And now, in the conventional software engineering world, the way we try to solve those problems is to design rules or hard-coded, quote-unquote, features to address those problems. And before the deep learning days, one really widely adopted approach is called histogramic gradients. What it does is basically it finds edges of different directions, this direction, that direction, and try to collect the statistics locally as a way to describe what kind of things are going on in this image. So this is one example when you look at a car through this histogram hawk kind of feature. If you look really carefully, you can kind of see that there are different, like a car-ish kind of stuff, round kind of stuff over there. It's not really great, but it's kind of like the way that we can use rules or hard-coded features to represent all those images. This is another view of a broader image. As we can see, it's an okay feature because you can kind of recognize there are, like buildings, trees, roads, and stuff like that in it, but it's not too much. If we want to use this to infer really complex information out of these images, it's really difficult, right? And then the question is, we're actually limited by logic to design features and to create features in that way. Now, a few years ago, a grad student called Alex Krzyzewski said, no, we don't need to do this. We can actually basically write building blocks in a very abstract way, what we call nowadays called convolutional neural nets, to basically design what kind of things we want to be there. And then we use a massive amount of data to infer what exactly they will do. And we basically went from the write-in logic to write models in the AI field. It worked really well, and surprisingly, it also has a pretty interesting biological backend of it. So in our visual cortex, we actually see that our brain is doing layered inference with neurons feeding information from layer to the next one, to the next one, to the next one, and extracting more and more complex information out of that. That gave us a really good win on the accuracy. So over the last few years, before deep learning started, we saw a plateauing effect of the hard-coded features of logic. So we were basically not able to get too good classification results. There's a benchmarking example called ImageNet that tries to recognize objects out of 1,000 categories, and we're able to basically get about 26% out of 5 guesses before we used deep learning features. And AlexNet in 2012 really made a breakthrough and had a really big jump in the accuracy that got everyone really excited about this field. So essentially what we are seeing in AI is that we're starting to replace logic that we hard code and we write in our software programs to thinking more about adaptive models that can basically derive a general rule for us to do computation and then use a massive amount of data and compute to get the exact computation out.